All right, today we are generating equivalent expressions. So generating means creating, equivalent means equal, and expressions we know are algebraic expressions. So we are creating equal expressions. We're going to do that a couple different ways today. So on your notes, the opening exercise we're going to do on the screen, you have a table of information. Mine won't be in a table, but you can plug your numbers right in. So as you can see across the top, it says 1 is the expression. The opposite of 1 is -1. And then they prove it by addition, that 1 plus -1 is 0. Let's do 3. What is the opposite of 3? It's -3. Our proof would be that 3 plus -3 is 0. Remember, opposites add to be 0. -7 is next. The opposite of -7 is +7. And our proof would be -7 plus 7 equals 0. Continuing through, we have -1/2. The opposite of -1/2 would be +1/2. And then -1/2 plus 1/2 is 0. Now we move into a variable, x. X is an unknown number, but we do know that it's positive. So the opposite of x would be -x. Then we move into a coefficient, 3 times x. The opposite of that would be -3x. Running out of room for the last two. I'm going to erase my last two rows so I have room to plug them back in. You guys have a table made for you. All right, so x plus 3 is our next expression. The opposite of x plus 3, you're going to change both terms. So we have a positive x, you need to make that a -x. And then we have a plus 3 or a +3. So you need to make that, you can keep your addition sign, but you need to make the 3 a negative. So that when you have a compound expression that has more than one part, you have to make both of those parts negative. Next we have 3x minus 7. So keep in mind what I said. If we're gonna do the opposite of this expression, both pieces, it's got two parts. It's got a 3x and it's got a -7, and both of those terms need to be switched to the opposite. So it's going to be -3x, and then instead of -7 we can do +7. So we'll prove some of this stuff in the slides that are next. So looking toward the bottom of your paper, it says example 1, subtracting expressions. First thing you need to understand is how many expressions do we have here. Here is our first expression, and here is our second expression. So expression number 1 and expression number 2. Since they're all integers, there's no variables, we can solve this using PEMDAS. So we can do 40 plus 9 is 49. We're simplifying that first expression. Bring down the minus sign. 30 plus 2 is 32. Now we still have two expressions, but they're simplified down to one term. Before, each expression had two terms, two pieces. Now both expressions just have one piece. We do 49 minus 32 and we'll get an answer of 17. So pretty simple if everything is integers. You just follow PEMDAS. A little more complicated will be part B, where it tells us to subtract these terms. Now, let's look at the first expression here. It is being subtracted from the second expression. The first expression has how many terms, how many pieces? Let's count them. 1, 2, 3. The second expression has 1, 2 pieces. When you combine expressions, you have to do something called combine like terms. We may or may not have talked about this before the lesson. What that means is you can't add or subtract terms if they don't have the same variable. So for instance, this 3x, the only other term that I can work with that 3x is the 4x because they both have the same variable. I can't combine a 3x and a 5y because they have a different variable. So they are not like terms. All right? Show you how that works. So we can look through and we know we are subtracting. So first thing I'm going to do is I'm going to find a term here that is 3x minus 4x. Those are like terms. So I'm going to show my math for that. It's 3 minus 4. 3 minus 4 would equal negative 1. So these two terms that are circled are going to become negative 1x. Or just negative x because you don't need that coefficient of 1. So those two terms are done. Now we'll look to our y term. It is a plus or a positive 5y. Is there any other term that is left that we could combine with that one? No. So we just bring it down. And then we look at our integers. We have a minus or a negative 4, take away 11. So I'm going to show that work off to the side. It was negative 4, take away 11. That answer would be negative 15. So that number goes here on our new expression and we're done. We have created an equivalent expression. This new one is exactly the same as the first one. It just looks simpler. This next strategy works a little better when you're new to this, and it's going to be doing the same process, but we're going to stack them up instead. So here's what I mean. It helps you with combining like terms if you're confused by that. This expression says 5a plus 3b minus 6c plus 2a minus 4b plus 13c. This one says to align the expressions vertically, or in other words, stack them up. So let's take our first expression, 5a plus 3b minus 6c plus 2a minus 4b plus 13c. Now as you can see, our like terms are lined up. 5 and 2a are lined up. 3b and 4b are lined up. And now you just go through like you would a normal addition problem, just being careful of the signs. So let's look here first. Change my color. We're going to add up this column. It is a positive 5a plus a positive 2a. That's 7a. Next column, it is a positive 3b. I'm going to show this off to the side. That's 3b positive plus negative 4b. So you got to be careful here. That one's going to be negative 1b or just negative b. So negative or minus b. And then our last column, we have a negative 6c plus positive 13c. Negative 6 and positive 13 is 7, positive 7. So we're going to put positive or plus 7c, and we're done. So this expression that we made is equivalent to this big expression. just in a much simpler form. Okay, last one we're going to have time for on the video, and then we will finish example 3 and 4 together as a class. Part B wants us to do the same thing. We're going to align these expressions vertically, and we're going to try to make a new equivalent expression, because this one's pretty complex. It's got a lot of pieces. So let's stack up our terms. 2x, writing the first expression here, 3y minus 4, and we're going to stack the other expression under it. So here's our second expression. Line up your terms. It's going to be 5x plus 2. Now line up the 2 with your 4 because it's just an integer, it's just a constant term. And then there won't be anything here underneath the 3y, it's going to be empty. That's okay. Keeping in mind that we are subtracting, if you read carefully, it's 2x plus 3y minus 4 minus 5x plus 2. So we're subtracting these expressions. Got to be careful of that. Here we go. So it's 2x minus 5x. 2 minus 5 is negative 3x. Next terms, we got 3y minus nothing. 3y minus nothing. It would just stay 3y. It's a positive, so we're going to put a plus sign here. You got to have signs to separate your terms. So it's a positive 3y. Last step, negative 4 minus 2. Going to be negative 6. Negative 6. And we're done. So this expression is equivalent to this new expression. If we picked a value for x and y, we would get the same answer in both expressions.